Okay, so number 26 is the fifth root of negative 192 x to the ninth y to the sixth. So what you need to do is think about, first off, the fifth root. So I look across the powers at 5. 2 to the fifth is 32, 3 to the fifth is 243. That's already too large, yeah? So I've got 192, so okay, so 192 is not in my list of perfect powers of 5. So I need to see what I can simplify out of it. 192 is, let's see, 192, if I cut that in half, that's 81 times 2. Yeah? No, just kidding. 192. Oh my gosh, I'm fired. Okay. 192. Does 32 go into it? I don't know. Let's see. I don't think 192 is on there anywhere. So I'm just going to start cutting it in half and breaking it down. Although last time I couldn't. So 2 times. So let's go 96. Is that right? 2 times 96, 100. 2 times 90 is 180. 2 times 6 is 12. So, okay, good. So then 96, 2 times, let's go 48. Okay, so 48 is not on my list either, but it is 2 times 2 times 2 times 24, and 24 is 2 times 12, which is 2 times 6, which is 2 times 3. Good gosh. Okay, so that's 2 times 2 times 2 times 2 times 12. So 1, 2, 3, 4, 5, 6. 2 to the 6 times 3. That's 2 to the 6. 64. 64 times 3. Yeah, that makes sense. Okay, so when I take the fifth root, sorry, I'm like all over the place with this. The fifth root, well, first off, the fifth root of a negative. Okay, if it's an even root of a negative, then I can't take it. If it's an odd root of a negative, then it's negative. Okay, so the fifth root of a negative 192, which is 2 to the 6 times 3. So just like with the 9 and or the x and the y, I think, well, how many times, because I've broken it down into things with powers, right? How many times does 5 go into 6? It goes into it once with 1 left over. So, or I can think of it as 2 to the 5th times 2 times 3. Does that make sense? I can also think of it as 2 to the 5th times 6, which is a little bit easier to think of when you think about the fifth root, because the fifth root of 2 to the 5th is 2, and then you're just left with a 6 on the interior. But whatever. So the fifth root of a negative is a negative. 5 goes into 6 one time with 1 left over. The 3 doesn't simplify, so just got a 3 in there. 5 goes into 9 one time with 4 left over. And 5 goes into 6 one time with 1 left over. So my final answer is going to be, if I have any room, negative 2xy times the fifth root of 6x to the 4th y. Okay. So, number 27 is, guys, please don't make me yell at you again through the video. Let's be working. The square root of 100x squared y cubed. So 100 is actually just 10 squared. So the square root of 100 is 10. 2, the understood 2 goes into 2 one time with none left over. 2 goes into 3 one time with 1 left over. So that is my final answer. You don't actually need the power of 2 or the root 2 written, but why not? Number 28. I've got the square root of 144. The square root of 144 is 12. 2 goes into 1. Well, it doesn't. So that's left inside. 2 goes into 2 one time. And 2 goes into I was going to say z. 2 goes into 3 one time with 1 left over. And so that's my answer. On 29, we've got the fourth root of 243. So 243. I see is 3 to the 5th power. So I'm going to, instead of thinking it as that, I'm going to think of it as 3 to the 5th, and then just treat it the same way I treat those. 4. 4 goes into 5 one time with 1 left over. 4 goes into 8 twice with none left over. 4 goes into 14. 4 times 3 is 12, so I have 2 left over. And 4 goes into 7 one time with 3 left over. And there you go. My earring just fell. What's up? There's something that's wrong? I'm making a video, so.
Here it's 2, 3. This one is just 4.
It's 1/2. That's a horizontal compression by a factor of 1/2.
Oh, so this one is bottom?
Yes, the vertical is 3/2, so that's exactly 3/2, 3/2, 3/2. You multiply by 3/2.
Oh, vertical means.
Okay, number 30. Now we're multiplying these, so what I'm going to do is I'm going to combine, and then we're going to see what we can do. So I've got 6 times the square root of 2 times 20, which is 40. X to the 4 times x to the 3rd, which is x to the 7th. Y to the 6 times y to the 8th, which is y to the 14th. And that is a square root, so we're going to go from there. 40 is 4 times 10, so the perfect square that goes into it is 4. So as far as simplifying goes, the square root of 4 is 2, and I'm left with a 10 on the interior. 2 goes into 7 3 times with 1 left over, and 2 goes into 14 7 times with none left over, meaning my final answer is 12 x cubed y to the 7th times the square root of 10x. Number 31. I've got a -5 on the outside, so I'm going to write -5 times the cubed root of 24 times -10, which is -240. Or you could just say 24 times 10 and break it down. A to the 7th times a to the 4th is a to the 11th. B to the 10th times b to the 5th is b to the 15th. And c squared times c to the 5th is c to the 7th. So first off, an odd root of a negative number is negative. So these two negatives, when you bring that negative out, it actually makes it a positive. So we'll no longer have a negative. Okay? So let's talk 240. 240 is not on my list of anything. So let me look at powers of 3. 8. Let's see. 8 is a perfect cube. And 240 divided by 8 is 30. So if I take the cube root of that, that's the cube root of that. So the only, like, I'm looking for the largest perfect cube that goes into it, and 240 is between these two, right? 216 doesn't go into it, 125 does not go into it, 64 does not go into it, 27 does not go into it, 8 is the only one that does, and it goes into it 30 times, and the cube root of 8 is 2. So we'll bring a 2 on the outside, but I already have a 5. I have a -5, but remember these two negatives became a positive, so I'm going to say 5 times 2. And then write my cubed root, and I'm left with a 30 on the interior. 3 goes into 11 3 times. 3 times 3 is 9, so I'm left with 2. 3 goes into 15 5 times evenly with none left over, and 3 goes into 7 twice with 1 left over, making my final answer 10 a cubed b to the 5th c squared times the cubed root of 30 a squared c. Number 32. Oh no. Maybe I'll see with the yellow. I'll try it.
Here it's 12.5.
Because I cut it in half.
But this one is 11.5.
But you're coming from -1. So when I multiply, I've got 3 times -1 is -3. Yeah, you can't. That's not dark enough. 3 times negative 1 is negative 3. 3 times the square root of 2 is 3 square roots of 2. 5 square roots of 2 times negative 1 is negative 5 square roots of 2. And 5 square roots of 2 times the square root of 2. 5 square root of 2 times the square root of 2 is 5 times 2. Square root of 2 times square root of 2 is just 2, so that is plus 10. So final answer, combined like terms, I've got a 7 minus 2 root 2. 3 root 2 minus 5 root 2 is negative 2 root 2. And there you go. On 33, we are dividing by a rational expression, so that means you need to multiply by the conjugate, kind of like how we did with the imaginary terms. So we're going to multiply by 5 plus 5 root 3. Okay? The conjugate of the denominator. So here we go. I've got 20 plus 20 square roots of 3. Negative square root of 3 times 5 is negative 5 square roots of 3. And then negative square root of 3 times 5 square roots of 3 is negative 5 times the square root of 3 times the square root of 3, which is just 3, so negative 5 times 3. So negative square root of 3 times 5 square roots of 3 is negative 5 times 3, which is negative 15. In the denominator, we've got 25. 5 times 5 square roots of 3 is 25 square roots of 3. Negative 5 square roots of 3 times 5 is negative 25 square roots of 3. And negative 5 square roots of 3 times positive 5 square roots of 3 is negative 25 times 3, which is negative 75. So my numerator, I'm going to combine like terms. I've got 20 minus 15 is 5. 20 minus 5 is 15. So I've got 15 square roots of 3. 25 minus 75 is negative 50, and 25 square roots of 3 cancel each other out. So I'm left with, now, you should always float a negative to the top, so I'm going to make both of those negative in the numerator. But 5, 15, and 50 all divide by 5. So my answer is actually going to be negative 1 minus 3 square roots of 3 divided by 10. Float the negative to the top and divide everything by 5. Okay. Number 34, write it in radical form. So if I want to write this in radical form, then I get all of this is being raised to the 1/2 power. That means the root is 2, the power is 1, 5b goes in the interior. There you go. You don't have to write the power of 1, you don't have to write the power of 2. You could have just written this. Okay? As far as the next one goes, the root is on the bottom, so it is the 5th root of x cubed, or the 5th root of x cubed. The power can go inside with the root or outside, doesn't really matter. Number 36 says write it in exponential form, so basically just do the opposite of what we just did. So this is 3n raised to the power over root 7 over 4. And 37 is the x is being raised to the first power and the cubed root, so this is x to the 1 over 3 power. Alright, so on this one, we want to find 343 to the 2/3 power. This is without a calculator, so I'm going to think of it as the cubed root of 343, and then I'm going to square it. You could square it first, but without a calculator that would be quite ridiculous. So I'm going to take the cubed root of 343. So I look up across the powers of 3, and I see 343 is 7 cubed, meaning the cubed root of 343 is 7. So this is the same thing as 7 squared, which is 49. And there you go. 64 to the 1/2 really just means the square root, because it's a 2 and then a power of 1 of 64, which is just 8. The square root of 64 is 8. Number 40, when it has a negative power, that actually means it belongs in the denominator. So I'm going to do a couple things. I'm going to bring it to the denominator, and then I'm going to deal with the root. So it is a square root, because of the 2, of 81 to the 3rd power. The square root of 81 is 9. and 9 cubed is 729. So that is my final answer. On number 41, this one's a little different. I've got 27m to the 6 to the 5/3 power. So what I'm going to do is I'm going to think of it as the cubed root. Okay, I'm actually going to distribute it and deal with it that way. I've got 27 to the 5/3, which we'll figure out in a second, times m to the, well, when you raise something to a power, x squared cubed, that means x squared times x squared times x squared. Because you're cubing it means multiply it times itself 3 times. That adds up to x to the 6th. Meaning when you raise something to a power and then you raise that to another power, you've got to actually multiply 2 times 3, not add them. Okay, like we do when you multiply. Like x squared times x cubed. So this is 6 times 5/3 and 6 times 5/3. So you can think of it as 6 over 1 and multiply straight across. 6 times 5 divided by 3 times 1. And then divide. 6 times 5 is 30, and 30 divided by 3 is 10. Or you can think 6 divided by 3 is 2, and 2 times 5 is 10. Either way. Okay? So this is actually just m to the 10th power. Okay. So that is as simple as it gets. Let's deal with this one. I've got the cubed root of 27 to the 5th power. Roots on bottom, powers on top. The cubed root of 27 is 3, using our power chart. 3 cubed is 27. Therefore, the cubed root of 27 is 3. So I've got 3 to the 5th, and my power chart also tells me that 3 to the 5th is 243, which means my answer is 243 m to the 10th power. Alright, number 42. Number 42 has to do with simplifying these expressions. So let's talk about what we have to do. I'm going to leave this alone real quick and I'm going to deal with this. I've got 16x to the 1/2 power, which really just means 16 to the 1/2 times x to the 1/2. And the 16 to the 1/2 means the square root of 16, which is 4. So I've got negative 2x to the 2/5 times 4x to the 1/2. So negative 2 times 4 is negative 8. And when you multiply two variables, you got to add their powers. So I've got 2 over 5 plus 1 over 2. And in order to add two fractions, you've got to have a common denominator. The common denominator would be 10. So I multiply top and bottom by 2 on this side, and by 5 on this side. So I'm left with 4/10 plus 5/10, that is 9/10. So negative 8x to the 9 over 10. And that is what that simplifies down to. On 43, we want to simplify. You can think of it as subtracting 3 minus 5 is negative 2, which means it belongs in the denominator. I like just saying 3 of these simplify out with 3 of those, leave me with 2 in the denominator. 1 of these cancel out with 1 of those, leave me with 1 in the numerator. So my final answer is y over x squared. Number 44. I'm going to distribute this power of 3, negative 3. So negative 2 to the negative 3rd power really just means, so I'm going to go ahead and draw a fraction bar. Negative 2 to the negative 3rd just means negative 2 cubed in the denominator, okay? So then we'll take all the negative 2 and erase it to the 3rd power in the denominator. X to the 3rd to the negative 3rd just means x to the 9th in the denominator because it's x to the negative 9. Now y to the negative 4 to the negative 3rd means y to the positive 12, which means it stays in the numerator. And anything to the 0 power is just 1, so it doesn't matter. So my final answer, well, negative 2 cubed is actually negative 8, because negative 2 times negative 2 times negative 2 is negative 8. I'm going to float the negative to the top and say my answer is negative y to the 12th divided by 8x to the 9th. Because you can divide by a negative, it just floats to the top. It becomes negative, I guess. I could say. Okay. Number 45. So I'm just gonna, oh, computer froze, okay. I'm going to just start distributing and placing things where they belong. Okay, so 2 squared is 4. X cubed squared is x to the 6th. That is y to the negative 4, so it belongs on the bottom. Okay, the 3 stays on top, the x squared stays on top, the y stays on top, z squared moves to the bottom. Okay, I've got negative 2 to the negative 2nd power. That really just means negative 2 squared needs to move because it's to the negative 2 power. So I'm going to put negative 2 squared in the numerator. That is x to the negative 4, which means it belongs in the numerator. X to the 4, same thing, y to the 4. Now this is z to the 1st, so that's z squared on top. And then the denominator with the 3, x, y to the 4, z all being squared, I'm going to square those, and none of these have a negative power, which means they all belong in the denominator. 3 squared is 9, x squared, y to the 8th, and z squared. Okay. So there's a couple different ways to go from here. You can start simplifying in the numerator and simplifying in the denominator and then simplify vertically, or you can start canceling things out as you see it. That's very much up to you. I'm going to go ahead and combine what I see in the numerator and combine what I see in the denominator and then go from there. So, I've got a 4 times a negative 2 squared. Negative 2 squared is 4. 4 times 4 is 16. 16 times 3 is 48, or 4 times 3 is 12, and 12 times 4 is 48. So I've got 48 in the numerator. I've got 6x's, 2x's, 4x's, so that's 12x's. I've got 1y, I've got 4y's, I've got 5y's, and then I only have z squared in the numerator. In the denominator, I have a 9, I have 2x's, I have 4 and 8, so I have 12y's, and then I have 4z's. So then we simplify. 48 and 9 they do simplify. 48 divides by 3. Right, so, okay, well, I'll address that in a second. 48 divided by 3 is 16. 9 divided by 3 is 3. 2 of these cancel out with 2 of those, leave me with 10. 5 of these cancel out with 5 of these, leave me with 7. 2 of those cancel out with 2 of those, leave me with 2. Final answer, I've got 16 x to the 10th divided by 3 y to the 7th z squared. And that should be your final answer. But if I had wanted to, four x to the 6th times 3x squared y times 4x to the 4th y to the 4th z squared over y to the 4th z squared times 9 times x squared y to the 8th z squared. Okay, you could have been, if you wanted to, you could simplify as you see it. Like, I see those two z squares canceling out. I see this x squared and this x squared canceling each other out. I see y to the 4th and y to the 8th, so that leaves me with 4. 3 and 9, so that's 1 and 3. Let's see, what else do I see? One of these y's can cancel out with one of these y's, leave me with 3. And z's, no more z's on the top. X's, no more x's in the bottom. Okay, so let's see what we're left with. 4 times 4 is 16. X to the 10th, because I got x to the 6th and x to the 4th left over. Everything else looks canceled out. I've got a 3. Let's see, I've got y cubed and y to the 4th, that's y to the 7th. And then I've got z squared, which is the same thing. Okay, it's what you're comfortable with. It does not have to be one way versus the other. Okay. Number 46. On number 46, let's go ahead and, okay, right off the bat, I see that I've got a 2 and the 2 in the denominator. 2 divided by 2 is 1, so I might as well just simplify that out. Let me just place things where they belong. I've got a 3, an m to the 1/4. N to the negative 7/4 means n to the 7/4 belongs in the denominator, and n to the 4/3. Interesting. That's ugly. So the only thing I really need to simplify is n's. So I've got n to the first on top, and I've got n to the 7/4 and 4/3 on bottom. So what I want to do is I want to find a common denominator between 1, 4, and 3. So think of that as 1 over 1, which is 12. So I'm going to do that separately. N to the 1 over 1 divided by n to the 7 over 4 times n to the 4 over 3. So if I multiply this by 3 on top and bottom, and I multiply this by 4 on top and bottom, and I multiply this by 12 on top and bottom, then I've got n to the 12/12 divided by n to the 21/12 plus 16/12. 21/12 plus 16/12 is 37/12. So n to the 12/12 divided by n to the 37/12. And so it's like how many 12ths can simplify out? 12 can cancel out with these, leaving me with just 25. So that means n to the 25/12 in the denominator is the simplified version of that. So 3m to the 1/4 divided by n to the 25/12, which is super ugly, but it is the answer. Okay. Last, we've got number 47 on this page. So I'm going to distribute this power of -2 and place things where they belong. This, when I raise something to a power and then I multiply it times another power, or when I raise it to another power, I multiply them. So 3 halves times a -2 is just a -3. So I've got x to the -3, which means it belongs in the denominator. This right here becomes y to the +4, which means it stays in the top. And this becomes an x to the +2, which means it also stays in the top. X to the -5/3 in the denominator needs to move up to x to the +5/3. And y squared in the denominator needs to stay there. So then we need to simplify. Okay? So I see 2 y's from here canceling out 2 y's from there. 2 of these cancel out with 1. 2 of those leave me with 1. So I've got y squared x to the 5/3 divided by x to the first. So I'm going to find a common denominator, which is 3. Multiply top and bottom by 3 in the denominator. So I've got 3/3 in the denominator, 5/3 in the numerator. So 3 of these cancel out with 3 of those, leave me with 2. Yes? Okay. Yep. So final answer is x to the 2/3 y squared. And that is the end of page 4.